Let's review your MT2 LT4 affirmation right now. This first question, you should have kind of noticed something when you typed in the answers. You did this correctly for finding the rational root theorem, but the question isn't the rational root theorem. They want you to use Descartes' rule of signs to determine the possible number of positive and negative roots. You found all the possible positive roots and negative roots. But I want you to understand how to use Descartes' rule of signs, because you might end up taking a class where they don't let you use a calculator. Here's what we do. We count the sign changes for the positive roots. So if I look here, we start positive, it stays positive, it stays positive. Oh, it switches. So you have one sign change, so you have one positive root. It could go down by an even number, but in this case, you can't have less than 0. So you just have one positive real root. Now to find the number of negative roots, let me switch colors here so you can see the difference here. I want you to find P of negative x. So it'll be 5 times negative x cubed plus 3 times negative x squared plus 2 times negative x minus 3. Now let's simplify that. When you cube a negative, it's negative. A negative times a positive is negative. So the first one is going to be negative 5x cubed. When you square a negative, it's positive, so it's plus 3x squared. A negative times a positive is a negative 2x, and then minus 3. Now, let's count the sign changes. We start with negative, we go positive, that's one root. Or that's one sign change. From a positive to a negative, that's another sign change. And then from a negative to a negative, that's not any sign changes at all. So the number of negative roots, or possible negative roots, is going to be 2 or less than by an even number, or 0. So you'd have the negative roots could be 2 or 0. The positive roots could be 1. And that's all I wanted you to do on that question. Now, on this next question, I'm kind of confused what you did. I don't know where this 24x showed up from. I don't know why you substituted x plus 4 into the problem. Because if you have a root of 3 plus I, you must have 3 plus 3i, that is. You must have the conjugate root, which would be 3 minus 3i. So we definitely have 2 complex roots. However, there's a possible of 3 roots. We could multiply these together. In fact, I'm going to do that. So my roots are x minus 3 plus 3i and x minus 3 minus 3i. If I distribute my negative sign, I'm going to say x minus 3 minus 3i and x minus 3 plus 3i. I'm going to treat this as x minus 3 minus 3i and x minus 3 plus 3i. So in other words, I have a difference of squares. So when I multiply this together, I'm going to get x minus 3. Let me rewrite that. That looks terrible. X minus 3 squared minus 3i squared. Well, x minus 3 squared is x squared minus 6x plus 9. 3i squared would be 9i squared, which would be negative 9. When you subtract a negative, you end up with a positive, so x plus 9. So in other words, it's x squared minus 6x plus 18. Now let's see if there's another root. Now let's use long division. So I'm going to say x cubed minus 2x squared minus 6x plus 72. And I'm going to divide that by x squared minus 6x plus 18. Well, let me see here. X squared goes into x cubed x times. So we're going to get x cubed minus 6x squared plus 18x. Let's switch the signs. So 2x squared, or negative 2x squared plus 6x squared is going to be positive 4x squared. 18x, negative 18x minus 6x is negative 24x plus 72. Bring down the 72. Well, x squared goes into 4x squared 4 times. So 4 times x squared is 4x squared minus 24x plus 72. And notice they cancel to have no remainder. So one of my factors is x plus 4. Well, if x plus 4 equals 0, x equals negative 4. So your roots are going to be 3 plus 3i, 3 minus 3i, and negative 4. Now, I would be remiss if I didn't show you an easier way to do this problem. We know 3 plus 3i and 3 minus 3i are going to be roots. What you could have done after you got those two roots in, you could have graphed this. So if I go x cubed minus 2x squared minus 6x plus 72. Let me shrink that in a little bit so you can see a little bit more. You have one root at negative 4. Did I put negative 4 in there? Yeah, I did. I was concerned I put negative 4. And since you know it's a cubic, let me go back to the problem. Since we know it's a cubic, we know we have 3 roots. So 2 of my roots are complex. The third one was negative 4. So you could have saved yourself a little bit of work and time, but I wanted to, since I'm making the video, I want to show you both ways. Let's take a look at this one. This function below has at least one rational root. Use this fact to find all the zeros of the function. If there is more than one zero, separate them with a comma. Now, you use the rational root theorem to find the possible number of roots. And that's good. That's correct. But now you have to use synthetic division and try each one of these to find all the roots and see which one of them are actually roots and which ones are not. And like I said, that's what I had to do 30 years ago, 50 years ago, in the land before time. However, I think it's a lot easier if you would just graph this. So let's graph this to start with so we can eliminate some of our possible roots. So I'm going to type in 2x to the 4th minus 10x cubed minus 27x squared minus 8x plus 7. Now, I'm interested in the roots. So if I look at this first root, that's an irrational root. I'm not even going to try that. -1 is one of my roots. Irrational, +7 is one of my roots. So I'm going to use synthetic division. I'm going to start with -1. So we're going to go -1. I'll have 2x to the fourth, -10x cubed, minus 27x squared, minus 8x plus 7. I know this last one better be 0 if I'm doing it right. 4, 3, 2, 1, 0. So bring down the 2. That gives me -2, gives me -12. +12 gives me -15, gives me +15, which gives me 7, which gives me -7. Now let's try our other root. Our other root, remember, was 7. So I'm going to try 7. Whoops, get back here. And if this is a 0, if this is a root, this should be 0. So bring down the 2. 2 times 7 is 14. Minus 12 is 2. 2 times 7 is 14. I get -1. I get 7. Or -7, which gives me 0. Now remember, I've got 2 irrational roots. I got to find those. I can't find irrational roots by using synthetic division. However, every time you do synthetic division, you get a depressed polynomial. So this was 2x to the fourth. So this is 2x cubed. This is 2x squared. So in other words, I've got 2x squared plus 2x minus 1 equals 0. That does not factor. If it did factor, I'd have rational roots. So I'm going to use our friendly quadratic formula to find my other 2 irrational roots. So -b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to say -2 plus or minus, well, 2 squared is 4, minus 4 times a, which is 2, times c, which is -1, all over 2 times 2. So now it's just a question of simplifying. I'm going to rewrite this as -2 over 4 plus or minus. If I go 4 and then a negative times a negative is a positive, so 4 plus 8 all over 12. Or 4, I'm sorry. Getting ahead of myself. I can simplify -1/2 plus or minus the square root of 12 all over 4. Now I want to simplify that square root of 12 because we want the answer in lowest terms. So you get -1/2 plus or minus the square root of 12. Well, that's 2 square roots of 3, isn't it? All over 4. So we get -1/2 plus or minus the square root of 3 all over 2. Now, a lot of times you'll see that written as -1 plus or minus the square root of 3 all over 2. So we were supposed to list all the zeros. So in other words, our zeros are -1, +7, and -1 plus or minus the square root of 3 over 2. I don't know. If you have a plus or minus sign on your Alex, you can put that as 1. If not, you have to write -1 plus the square root of 3 over 2, comma, -1 minus the square root of 3 over 2. And there we have that problem.